under all different conditions. But in a lab, if you can satisfy the basic conditions of making sure that it works, it gives you the data that you need, it provides the function that it is designed for, that you have reached the 4th level. These first 4 levels are very important for an invention. And now, if you have data, if you collect the data in the lab, and you also did your research and found out what exists in the market, and if there's data about the product application and working conditions, then you have to satisfy the 5th level, which is comparing and making sure and proving that yours works better under at least lab conditions, laboratory conditions. And once you've done that, your invention is ready for example, invention competition. But it's not ready to be a marketable element yet. Now, to make it into a marketable element, you have to have a system model of it. You have to design the model, do analysis with the model, try different conditions for the model. For example, if it has to work under cold temperatures and hot temperatures, in your design analysis, in your modeling, you try different conditions and see what kind of responses you're getting, and maybe simulate that in the lab before you actually put it into a system and analyze all the complete details of working conditions in a system environment. Now, technology readiness levels 7, 8, and 9 are the most critical parts, because now you're getting into actual development, and even you're thinking about how to manufacture it, how to design it, how to design the manufacturing process, in other words. And you have to also consider the economic conditions, which means you have to find the easiest way of manufacturing. You have to have a system for which it is designed and therefore applied within the system itself, and demonstrate that the prototype actually works in the system. So these 3 levels, 7, 8, and 9, you qualify every single feature of your invention. Once you've done that, then you have completed all the details. Now we go to the example. This is the invention that Professor Gevorkyan has created. It's a vibration instrumentation. He can actually give us more details. If I somehow give the wrong impression, you please correct me. So if I give you any details that are not correct, he can correct me later on. So this is a prototype seismic sensor that was created in the lab in the Yerevan State University, and it has advantages over existing vibration sensors in the sense that it can sense nanometer vibrations, as I said before. So the device is an invention, obviously, because it can sense very small vibrations. And actually they showed that it is 10 to 20 times more sensitive than any existing vibration sensor in the market. For example, the American KS5400, which I'm not familiar with, but Professor Gevorkyan is, it's an American sensor that measures vibrations. It is 10 times more sensitive than the KS5400, which is used for security systems. In other words, they sense vibrations if there's any intruder, for example, at the border. If they have sensors all over the border, then they can detect any intruders or any...
It's important for Armenian Armenian.
It is also important for the Armenian, exactly, and I'm going to mention that. Actually, Levon and Professor Gevorkyan are trying to promote this technology to the Armenian military use, and they have actually been allocated certain, well, they have been allocated a budget, but it's not really funded yet. We hope that they will be funded eventually. So these are examples of similar devices that exist. There is a Russian SM3. This is 100 times more sensitive than the Russian instrument, and then 30 times better than the Swiss STS2, and as we said, 10 times better than the KS5400. It can be used to detect border intruders, as we said. So these are pictures just to give you an idea of what the use of this kind of invention could be. The various features, the steps that need to be taken. You have to find out what kind of disturbances occur. For example, if you want to identify also what the intruder looks like, or what kind of, how big it is, or whatever it is, then it means you have to identify the signature of that instrumentation, of the vibration. There are different signatures, obviously, that come from different kinds of vibrations. For example, earthquakes have a certain kind of a vibration. They're very low frequency. You all understand what frequency is, right? Mm-hmm. Low frequency in the sense that it could be maybe half a hertz up to 1 hertz, which means a hertz is movement or vibration per second. How many times it goes back and forth per second is a hertz, right? So the first step is you have to identify the signatures coming out of your sensor. So that's one way of identification of features of a certain invention. In other words, you can, for example, identify features by doing Fourier analysis and finding out what the frequency content is. Whether a truck has different frequency content from a tank, that is a good, important discriminating feature, right? So you have to identify certain discriminating features to be able to identify the differences between various intruders. So that could be one application. Now, what does it do? It's an absolute position sensing device. And it has a shift resolution of 10 angstroms at room temperature, which is, an angstrom is a very, very small measure. So that's one of the discriminating features. It has a wide frequency bandwidth, which means it can actually detect frequencies from very low hertz, 1 hertz. Professor Gevorkian can identify down to 1 hertz. Below 1 hertz even. So a fraction of a hertz.
Up to 0.
A fraction of a hertz.
Isn't absolute position sensing the same as 0 hertz?
It is sensing movement of moon during one day. So it senses very slow vibrations, very slow movement. That's why it is absolute
equivalent.
position.
Equivalent to
Absolute
0,
position
yes.
sensing is the same.
That's the same as being a 0 resolution, right? 0 frequency. Yeah. And up to 100 kilohertz, which is a pretty wide range. The relative resolution is 1 nanometer, correct?
So relative is 10 to minus 6.
10 to the minus 6 meters, right?
Relative.
Oh, relative is the ratio. Yeah, it has no unit, right? So it is 10 to the minus 6. The power of absorption of the unit is 10 to the minus 10 watts, which is actually very low power unit, which means it doesn't use a lot of power. And that's another feature that you can sell. So you have to find what features you can talk about to customers, and they would like to hear that. For example, power is very important. If it uses a lot of energy, then you need to replace the battery so often that it becomes useless. So if it uses less battery or less power than another instrument, that's an advantage. So you have to provide all the advantages.
So it detects all these small things, but then it's disadvantage too, because it will be false alarms then.
Well, that depends on how you can analyze the signatures coming from the vibration and for sure identify all the features that can tell you what it is that is vibrating. So that depends on your programming, analysis tools, and